Hello, everyone, and thank you for joining us. We are going to start in just a few minutes to allow folks to join us on the various platforms we have. So we'll be with you in just a couple minutes. And if you haven't already, now would be a great time for you to grab your cup of coffee or whatever beverage you'd like while we get ready for our presentation. We are just going to give it one more minute and we'll start at about 11:03. Okay, well, let's get started. I want to welcome everybody today to the Wallarm workshop, API Threat Simulation with Open Source Tools. My name is Melissa Russell, and I'll be your host for today's session. Just a few housekeeping items before we begin. We will be recording the session, and we will make the recording and the slides available afterwards. If you have any questions during the presentation, please go ahead and enter them into the Q&A box, and we will save some time at the end to answer them. At this point, I'm very excited to introduce our speaker today, Wesley Thijs. Wesley is the Chief Executive Officer of the XSS Rat. Throughout his career as a QA engineer, Wesley has had a tremendous amount of contact with APIs and has been the author of numerous API security courses. Wesley, I really want to thank you again for joining us today, and please take it from here.
Thank you very much, Melissa. Pleasure to be here. Welcome, everybody. Hope you're all doing well today, amazing hackers. So I'd like to start off by introducing myself a little bit. My name is Wesley. I'm 30 years old. My background consists of mostly IT experience. I've been programming for 30 years, doing networking and QA experience. And I've been hacking for about 2 years. In those 2 years, I've tried to prove myself by doing some bug bounties. And in a period of 2 months, I found 30 bug bounties that were valid. And at that point, I moved on and I became more of a pen tester. So that's what I do with my company now, mostly pen testing, with a heavy focus on APIs, of course. We've also authored several API courses with the company. And before we start, I'd like to ask you all what you think of when I talk about an API, because API is a very broad term and I have a feeling it's thrown around a lot these days, but an application programming interface allows basically two applications to talk to each other. It's an interface for your application. So the term is very broad. And an API looks very different depending on who's looking at it, depending on what perspective we take. Because when we talk about backend developers, for example, they mostly look at frameworks and API specifications. That's what keeps them up at night. They don't talk about UI elements very much, and they're more focused on the data, the logic that's behind the scenes. Basically, it's a unifying backend for mobile, web, and integrations. That's what an API means to a backend developer. As a DevOps engineer, they mostly think about the specifications and how they meet the production requirements. For example, should this endpoint return a 502 that often? What should be the occurrence rate of a 200 versus a 403 forbidden? Scaling as well, that's also something that's important. Horizontal and vertical scaling both into consideration, of course. For example, how many microservices should we have? Should we increase the size of our microservices? That's something that keeps them up at night because, of course, they want to solve the issues that come out of the production requirements. And then, of course, the security engineers as well. For security engineers, they focus more on the protocols that come out. So new protocols, do their tools run against those protocols? The scanners, the firewalls, are they even recognizing that protocol? That's important to a security engineer. And also, of course, east-west security, which means are two hosts on either side of the network, on either parts of the network, talking to each other. They're also, of course, when new compliance comes out, a security engineer is very worried about that. They have to be in order with that new compliance, but they also have to check new devices for that new compliance as well. So that's what keeps security engineers up when they think about APIs. As you can see, everybody has their own standpoint on APIs. And the OWASP organization, they've been so kind to compose a security top 10 for APIs. They've basically divided 10 different issue categories which occur most on APIs. In this case, we can divide those further into 3 groups. We can see that they're divided into authentication, which broken user authentication belongs to, the authorizations, which the broken object level authorization, the broken function level authorization belong to. And then, of course, we also have threat preventions, such as excessive data exposure, lack of resource and rate limiting, mass assignment, security misconfiguration, injection, improper asset management, and insufficient logging and monitoring. So for the OWASP API top 10, we can see that we can make this division specifically. Now, those come into play later on. I want to first talk about the difference between attack simulation and fuzzing, especially because fuzzing itself seems to be the king of attacks, right? So you find an endpoint, what do? You try fuzzing it. You have a WAF installed, you try to break its security. What do? You try to fuzz it, of course. Or is it? Because there might be some better solutions out there. If you think about it, fuzzing payload means that we basically throw everything that we can think of at the endpoint. But when we talk about attack payloads, they have a certain overload with those fuzzing payloads because, of course, some of our attack payloads are going to be the same as those fuzzing payloads, but we can keep this group a lot smaller, as you can see. And that's going to be very useful when we look at it later, because if we look at this little dot right here, that is us and an infinite amount of fuzzing payloads and a growing, ever-expanding universe. So if we want to really test everything, that's impossible. Everybody knows that. But what do you test and what's a smart testing strategy? The amount of payloads is not the only difference, of course. The attack behaviors are also different because, while it's really hard for fuzzing presets and known attacks only, fuzzing also requires a deep understanding of the API business logic because, of course, you want to fuzz the correct things. If you want to attack something, you want to fuzz the business logic of that API. Some attack templates or attack payloads, these exist of templates, presets, known attacks, etc. If we look at some of the tools that are out there, and we'll be demoing some of these tools as well, if we look at REST, if we want to test the REST protocol, we can see that fuzzing on one stateless endpoint, we have certain tools here, Rat, Schematicus, Zap. We also, if we want to do some brute forcing, we have certain tools like ZAP, AP, curl. And if we want to do known stateless attack simulations, we can do ZAP and GoTestWAF. For GraphQL, we can see something very similar, only here we can see schematics in a ZAP. The ZAP seems to be a recurring theme. Only at gRPC, we see a few missing here. And for the node and stateless attacks, only GoTestWAF is possible there. We see for the WebSockets, XML, RPC, and SOAP, if you want to fuzz one stateless endpoint, that we can only use ZAP. And for speed limit attacks, of course, we can use ZAP, AB, and curl often. Now, for custom APIs, ZAP with extensions, we can see that there's quite a few tools out there. ZAP is a very powerful proxy with a graphical user interface, so it's basically a man in the middle. It's OWASP driven, that's why we looked at the OWASP before, but there's no gRPC support. And challenging for automation as well, because you have to do some traffic sample analysis behind the automation. It's not just automatic as some of the other tools are. For Wrestler and Dread, those are based on Swagger and OpenAPI. They are fuzzers. They're really good for stateless endpoint automated testing, but that's their specialty. In schematics, we see that it's basically Wrestler/Dread, but with GraphQL support in there. A/B test, JMeter, Yandex Tank, they're load generators, and they could easily be used for rate limiting checks, brute forcing attacks, credential stuffing, and rate limits, especially tools like AB and JMeter. You can do a lot with traffic manipulation. You can gather all of your traffic at one point and fire 10,000 requests at once with these tools. They're really useful for that kind of work. GoTestWAF, on the other hand, it's a simple attack simulation CLI tool, and it has out-of-the-box PDF reports. We'll look at those reports as well. Out of the box, by the way, those reports have recently been enhanced as well, so great on them. gRPC is also out of the box supported, GraphQL, WebSockets, REST support, and it's basically the only gRPC attack generator that we found. If you found anything else, please let us know, of course, because we would love to know about them. As for fuzzing stories, from something that we've seen in actual production occur, what we can do is we can try method scraping, for example. We'll look more into that later. Type miscasting as well. Last bit modification, where we try to replace the last bit with a null byte, for example. Random byte modification, I should say, where we try to replace one of the bytes with a null byte. We can add a payload to the end. We can try to add parameters from other requests, for example, passwords, if you log out, and a number increasing, decreasing, as you can see right here, and go back to that. We can try to increase or decrease the user identifier to see their status. We can also fuzz by file names, for example, fuzz.txt, which is on GitHub. Now, fuzzing optimizations for lists that we can apply is, for example, we need to know the context first when we're fuzzing with certain lists. And to know that context, we can apply machine learning. Everything from HMM to RNN is possible. We can also try to apply linguistics patterns for verbs and nouns. And we can try to apply templates as well. Now, we've included a link in here. If you want, feel free to look into that some more. An example 1.1 that we can give is a byte fuzzer, which in this case, we will try to induce memory corruption in the Nginx module by inducing a null byte in there. And that might allow us for random memory reading, something very similar to the Heartbleed bug for SSL. Another example that we can give is, again, byte fuzzing. And in this case, we're going to try SSRF inside of the URL string to the backend API. In this case, you can see that the method is test, and we try to add another method in there to delete the user. The call is going to be like this. And if we translate it, it's going to be a get call to the API with the method test. And behind it is going to be the method delete user with the host internal.api.host. So we can try to attack in this way as well. Another fuzzing method that we can do is we can try to do command execution as well, remote command execution by new line injection. So as you can see right here, this has been also known as the Yandex RCE, and there's a specific ticket about that as well, so you can look more into that. And in here, this is the market feed parser. It's another RCE in Python, and it's not covered by standard payloads as this, but it is covered by the new line injection that we see right here. So that's also an interesting fuzzing technique that we can use, of course. Another byte fuzzing method that we can do is, as you can see right here, we can try to add a payload which might give us an HTTP 200 status, while this payload might give us an HTTP 500 status. And in this instance, $1,000 was rewarded for injection into JSON to Elasticsearch. It might be an RCE, but more research into that is needed. The fifth example that we can have for you is if we make a get call to basically the /path, we have a cookie with a session ID. We can try byte fuzzing in there as well in our cookies. So if we try to add a new line in here, new line byte is a trigger for server timeouts. And as you can see right here, we also have, again, a link in there where you can look more into that. And this is going to try to affect the memory. We can also do list-based fuzzing. And in list-based fuzzing, we can see here that we have, for example, API/internal, API/internal. When then we know that we need to fuzz that endpoint/API/internal, of course. Then the seventh example is, for example, here we all know the standard HTTP methods, post, get, delete, put, but for some developers, they might try to implement their own HTTP methods, like we see this person doing right here. He's also included draft, validate, and curate. Now we can also have a set method, for example. HTTP non-CRUD methods is what they're often called, or the CRUD aliases for the web dev thing. So that's also possible. To remove right here is another verb for the delete method, but nobody knows why that's implemented. There's no special, or at least we don't know why it's implemented. There's no specialty there. There's the set method, you have the debug method, track, forward, move, and info. And if you want to know how to find them, you just run a fuzzing list by fuzzing all of these specific verbs. We just replace this verb with the list of verbs for your specific endpoint that you're fuzzing, of course. Now for these fuzzing nouns, I'm going to open this real quick and I'm going to show it to you because this is a template. And this is a template. What it's basically going to do is it's going to try to fuzz the what comes behind the slash. So if we look at our endpoint right here, post/endpoint/env, what this template here is going to do is it's going to try to fuzz all of these different nouns right here, and then it's gonna do it in the action name. It's gonna replace the action name with all of these, and then it's gonna try to do some detection on them as well. We'll get more into these templates later on. This is also related to the Trillopia by Artsploit Veracode, so the CV 2019. Then we move on to typecasting, because in this instance, we see that the token equals true. That's a variable, that's a Boolean. But what might happen is that an empty array might also be seen as a Boolean in some programming languages. So we might try fuzzes that. There might be other programming languages that see one as a true as well, so we might try to fuzz that as well. That's what typecasting is. We try an integer, might be seen as a Boolean. We try to do a empty array, might be seen as a true Boolean as well. Another example we have for that is we can't only typecast like we saw right here, like these values, but we can also try to typecast the content type, for example. That might give some unexpected results, like things that are allowed on the XML endpoint, which are not allowed on the JSON endpoint, for example. So that never hurts to try typecasting there. So if we take all of this into account, we basically get the hacker's view of our API request. And in the hacker's view of our API request, we start with a verb, we add a delimiter, we add a noun in there, which is user in this case. We add another delimiter, an indicator, which will be the user ID in this case, and then another delimiter followed by a verb. So that's our hacker's view. We try to look at it that way, because then fuzzing becomes a lot easier. Of course, we can try to fuzz these verbs. We can try to fuzz, let me go back quick. We can try to fuzz the nouns, or we can try to fuzz indicators. Analyzing the results. So some of these scanners, they'll produce vulnerabilities and false positives. False positives can be a really big problem because they can waste a lot of time. Some fuzzers produce abnormalities. So how are we going to analyze all of this data? Because it's a lot of work. And of course, we don't want to move this off to our intern if a computer can do it. So we also have the collaboration/integration problem. And then there are some testing policy examples. Like, for example, none of the results can contain 500 status codes. None of the results can take longer than a millisecond. There is not allowed to be more than 20% for 100 status codes. So these testing policies might also be in place and might need to be tested against the results, of course. Now, as for API attacks, we have certain tools. I'm going to show you a tool later on, but first I'm going to talk about GoTestWAF, and then I'm going to show you some other tools as well. GoTestWAF is an API/WAF test automation tool, open source. So if you want to look at the source code, it's possible. If you want to contribute, please do. It's testing for false positives and false negatives. And it supports REST, GraphQL, SOAP XML, WebSockets, JSON, and gRPC. There's multiple stack encoding support. So for example, if you want to if you want to URL encode something and you still want to base64 encode the parameters, that's possible. Or if you want to JSON encode something and then base64 encode that, also possible. There's codeless checks because we work with YAML files on that tool, and it's Dockerized, so really easy to install with out-of-the-box PDF reports. And there's a lot of community payload as well. Thank you very much, Volners, for creating those. It's really helpful to these kinds of tools to have the community support their own templates as well. So how does it work? It's basically a structure of a folder test case. Under that, there's the test case, then a test set, which is a YAML file. And then in that YAML file, you will find a payload, an encoder, and a placeholder. There's a false positive in there, a file false positive, a folder, and that's reserved for false positive test cases. So it's testing for false positives as well. And every test/check is basically a YAML file with 3 simple array sections. We'll be looking at that later as well, because it might not be making as much sense right now. But we basically have a payload, an encoder, and a placeholder. Now, the amount of requests that GoTestWAF sends is equal to the multiplication of the following. Basically, you have payload times encoder times placeholder, which means that if you have 5 payloads with 1 encoder and 1 placeholder, it's going to send 5 requests. If you have 5 payloads with 2 encoders and 1 placeholder, it's going to send 10 requests. If you have 5 payloads, 2 encoders, 2 placeholders, going to send 20 requests. So as you can see, it might get big fast. So the bigger your file is, the more it might send requests out. As for testing for false positives, it's really imperative to test for false positives. Even more detailed testing than for false negatives is needed because we want to avoid unavoidable and unpredictable effects in production environments. One of the ways to look for these false positives is to detect them early. So to do that, we can, of course, obviously check for false positives for mod security. We can try to do that. Mod security is an open source WAF based on regular expressions and lib injection library. So it will basically inspect the traffic and either approve or deny it. And we want what the team did was they decided to download and split by lines 899 books from the Gutenberg library. If you want to learn more about that, again, there's a link with an article in there. So feel free to look into that. It's quite interesting, really. So I would really recommend it. Then, of course, there's also the PDF output. We'll look more into that later. And as I said before, this has been given an upgrade recently. Now onto the demo. So for the demo, what I'm going to do is, first of all, I'm going to quickly go to the page for, this is the page for GoTestWAF. This is the GitHub page. So it's really easy to install. You basically execute the Docker pull command. Oh, there we go. I'm going to launch this as well. So you execute the Docker pull command to download the GoTestWAF image. I already have that on my system. And then you can run it. Now, if you run it, of course, you want to run it against a specific URL. I have mod security installed on this server on port 8080. So we can automatically test that as well. Just let it down real quick. I think it's downloading the update. There we go. And now I can run my command. And if I do that, I see that it's sending all of these requests out. I'm going to let it run for a second while we look at some other tools. But it's, oops, sorry. Basically, it's going to make all of the requests which are in the test cases folder. Now, if we go up here real quick, we can see that test cases folder is being pulled into the Docker file, by the way. And here we can see those false positive test cases that we were talking about. And we can also see some community test cases which have been made. As you can see, community LFI, RCE, SQL injection, XSS, and XXE. Now let's look at local file inclusion real quick. As you can see, they've made some payloads for local file inclusion, and we want to URL encode all of this. And we want to place all of these payloads in the URL parameters in HTML forms, HTML multi-part forms, and in JSON requests. And then we're testing for LFI in this case. So what it's going to do is it's going to execute all of these requests against mod security, and it's going to see if mod security is stopping all of these requests to test if it's actually doing its work. As you can see, it's running that right now. Now, there are some more advanced things you can do, of course. You can also add testers in here to see if it's properly coming in. So I'm just looking for one. As you can see, this is a very big one because there are quite a lot of cross-site scripting payloads in here. And all of these payloads are being URL encoded and sent in all of these different parameters, which is great. If you ask me, that's already testing for quite a lot. And this is the OWASP API top 10, which is being tested. And as you can see, gRPC is supported in this version. So gRPC is also executed. And also we have GraphQL, REST and SOAP. And we have the normal OWASP top 10, which is also being tested in here. As you can see, there's quite a lot of issues and they all belong to the OWASP top 10. So as my tool is running, it's gonna produce some reports for me as well, which we will have a look at in a moment. I'm quickly gonna show you some other tools as well, because the company Yellow, they produced this tool called Fuzz Lightyear. And Fuzz Lightyear is also really easy to install. And let me just quickly go there. So you just pip install Fuzz Lightyear, and that's it. It's installed. Then you can run it against, for example, the swagger.json. If we look at this pet store, it's an open API specification in this case. So if we go there, we can see, go there real quick. There we go. We can see the API definition in here. Now, what this tool is going to do is it's also going to test this API definition. And we can run this tool and it's going to test that API definition. Let me run it real quick. So there we go. And this is the report that was generated by our tool GoTestWAF. I'm going to enlarge the results a little bit. I can't enlarge them too big, but we will look at the PDF report later as well, of course. And in here, we can see false positive test cases that have been run, negative test cases. And in here, we can see which results bypassed and which results were unresolved. Now, of course, this is just a basic overview of what happened. But if we go to the server, we can actually see that there is a PDF and a CSV file being generated as well. Now, this PDF file, if we open it real quick, sorry, I see I'm opening the CSV file. Let me open the PDF file first. So if we open a PDF file, we can actually click through and see what's wrong. So let's open it, continue. And let's go to our download so we can open it. There we go. Solution evaluation, there we go. So the testing guide right here, we can see that the same thing happened. We have this overview right here, but we can also see the positive tests in detail and the status codes that we got. And then we have 21 true positive results identified as bypassed. And we can see that these results bypass the mod security that we've installed. So that means my regular expressions aren't quite as good as I expected them to be. And I might have to take another look at them. We also, if we go back to our, there we go. We go back to our command line for a second. I'm going to run a tool, the Fuzz Lightyear, developed by Yelp. And I'm going to run this tool against that Swagger JSON that we just saw, that JSON file. And in here, we can see that there are two warnings being generated on pet.add. There was a validation warning for the Swagger definition. Definition tag with siblings will be overwritten. We also have a pet.findByTags issue. FindByTags has now been deprecated. So as you can see, 3 items failed, 17 passed. And if we put our mod security over there, it's the same thing, of course. We're going to be testing our mod security. Now, these are some tools. I also have OWASP API in front of me. OWASP API, if I pointed to what I have installed on my mod security, I can also attack it, and that's also dynamically going to try to attack my mod security. And I have a lot of these tools which are available. One of those tools is Wrestler. I don't have it installed on my computer at the moment, but Wrestler is being developed by Microsoft. It also takes your Swagger specifications. It compiles them with its Wrestler compiler into Wrestler grammar, and then it feeds it to the testing engine, which will also give you bugs eventually. You can exactly point this at your mod security as well, and you're testing your mod security. Now, I'm talking a lot about that, but of course, you can test any firewall that you have installed, any WAF that you have installed. Doesn't have to be limited to mod security. there's also this cool tool called Open API Fuzzer. Now it runs a little bit long on, no, sorry, this is the one that needs Rust installed. So this is running on Rust. And again, it's gonna do the same thing, very similar at least. It's gonna try to fuzz your APIs based on your Open API specification. So again, you're gonna need to feed it some kind of API specifications. It's gonna test that API. You can put your firewall in front of it. So as you can see, there's quite a lot of tools in there. And that's about it for the demo. We can now move on to what's next, because I want to talk a little bit more about what's coming up in the next GoTestWAF releases. And there's more in tech types coming. So we're going to include Java, Python, .NET serialization attacks. There's going to even be more. And then, of course, there's also going to be a service mode, which allows you to integrate it with your CI/CD pipelines. And all your requests are always welcome. So if you have a pull request, please go over to GoTestWAF/pools and try to make your pull request. They're very welcome. If you want, please give us a star in GitHub as well. It's much appreciated. Thank you very much, everybody. And I would like to ask if there are any more questions, please pop them in the Q&A box and we can answer them for you. I see that there are some questions already.
And Wesley, just as a heads up, there are also quite a few questions in the chat as well. So if you pop open after the Q&A, go to the chat. And we're also checking on LinkedIn right now because we had a couple come in there too. So I'll ping you when I get them.
Awesome. Thank you very much, Melissa. So Jamil is asking, what backend frameworks are typically used for APIs, i.e. Spring Boot, etc., or add-ons are best to handle and mitigate are almost flooding techniques? Well, that's a two-part question. For the API backend question, it really depends on what front-end technology you're using, of course, because most APIs, you can build an API in Python if you want. It's very easy to build an API in Python. You don't have to use a framework necessarily, but frameworks, they're just there to make the life of the developer easy. And I think every single one of them has a specific advantage. It just depends on what situation you're in, to what API framework you're going to use. I hope that answered your question. And what add-ons are best to handle and mitigate all or most fuzzing attacks? Well, if you want to mitigate fuzzing attacks, it's best to rate limit properly. Because if you set up a rate limit, which doesn't allow for fast fuzzing, then the fuzzer can take an eternity to fuzz, but it's not going to help them much. So anything rate related is going to help you quite a lot there. And also, I think that would be most helpful there. I see that we have some questions indeed in the chat as well. Hello, and I'm curious, in what ways does fuzzing differ from chaos testing? That's a great question. I'll have to look it up and get back to you on that, Aaron. Manuel Walder is asking, oh, streaming is not working. Yes, there will be a recording, definitely. Yes, definitely a recording. A lot of people are asking if there will be a recording. The PowerPoints will be shared as well. Last I looked at Fuzz Lightyear, it didn't handle Swagger OS 3.x. Has it been fixed? That's a great question, Aaron. I also can't answer you on that. That's a great question, though. I'm going to have to look into that because that's quite interesting. Can we have the report as JSON files? No, not at the moment, but that would be an interesting feature to add. So if you want, definitely make sure that you make a pull request, and we'd definitely be happy to have that. It doesn't appear that the Fuzz Lightyear issue has been fixed, so apparently not. Thanks for answering your own question, Aaron. Really appreciate that. Amit is asking, good tool for automated API testing, business logic, or auth issues. I use Postman for that because with Postman, especially in the latest version, you can add flows. And the cool thing about those flows is that you can add conditions as well. And those conditions, they're going to allow you to put certain requests in an order, and then you can add an if statement, an else statement, certain loops. And those workflows are extremely useful. Above that, you can also put things into a collection, and then you can play that collection in a certain order. And you can automate that a lot by adding a CSV file, for example, into the question. That's also possible. You can add CSV files for fuzzing, and then you can replace certain values with the values you want to fuzz. Now, this is the flows window that I was talking about. As you can see, I can add certain requests in here with conditions, even terminal commands, variables that I can create here, JSON to be parsed. So there's a lot of things I can do with these workflows. That's very useful, and I'm definitely going to look into that a lot more. But for now, collections are one of my most useful things because I can just run an entire collection, add a CSV file in there, and I'm fuzzing. It can be as easy as that. Or you can use JMeter if you want with a CSV file. That's also possible. Thank you for that question. That's true. We can do that on the next webinar, possibly, how to fuzz APIs. Just to clarify the question, I was asking if there are server-side tools that can be deployed to the server. I mean, add-on to Spring Boot that helps with fuzzing, mitigating, and rate limiting. For example, Java is statically typed, so the list equals Boolean is not an issue. But maybe with a JavaScript backend, I'm looking for suggestions on backend things I can look into install into boot Flask or Django to mitigate some degree fuzz attacks out of the box. That's a great question. I don't have any direct answers to that, but I'm definitely going to be looking that up, and I'll pass that on to be sent along with the PowerPoint. So I'll add that into the slides, but that's a great question. I'll add that in before we send them over. Thank you very much for that. I don't know if we have any other questions come in.
Give me 1 second. I'm just checking the chat here.
Sure.
Couple more. Are there any sandboxed type APIs that are intentionally vulnerable that people can play around with the different types of the API issues?
Definitely. I have certain ones, like for example, API Goat is the one that you can mess around with a little bit, and they have a lot of vulnerabilities in there. And there was also another one, but I can't remember it out of the top of my head. But there is another API that's vulnerable. Let me quickly look it up. Oh, APIs. There are several. So you have this one by Matt Veldis / vulnerable API. That's also a good one you can test on. And there's an enhanced version of that as well. So these are easy to install, as you can see. Juice Shop has some APIs too. I think so. I'm not 100% sure, but that's a good. Juice Shop might have some APIs as well. What's the best way to hunt for P1, P2 bugs? That's a very broad question, Harsh. And for APIs, well, just get a remote code execution as the answer. I know it's an easy answer, but it's also a very broad question. So I would focus on things like remote code executions, things that impact the company a lot. That's very important whenever you're testing, whether it's pen testing, bug bounty hunting. If you're testing an API and you find a vulnerability, make sure that you also take the company into account and take the impact of the company into account. Amit also says crappy is so crap API is also one of the vulnerable services that we can use, and it uses Docker, so that's really easy to install. Thank you very much. Apparently also Vampy is what Our caches. Wow, these are some really useful tools. I didn't even know most of these exist, but vulnerable API. Apparently, Vampy is also a book, so. And of course, if you want to, there's also, you can go to hexpert.com before I forget, /labs, PHP. And in there's also a vulnerable API you can play with, basically. So this is about the API top 10 that we just looked into. You can basically learn about the vulnerability. You can open up to lab, which starts a Python API in the background, and then you can interact with it and try to find the vulnerability in there. So there's definitely a lot of options. Don't know if there were any more questions.
I think we are done with the questions. So Wesley, first of all, thank you so much for such an amazing presentation. I did also want to let everyone know, I do know there were several questions about the recording. We will make the recording and the slides available. If you have any questions or would like to try out the Wallarm products, you can schedule a demo and also go to wallarm.com and book a presentation there too. I did want to let everyone know we do have another webinar coming up next week on December 16th with Barak Engel. So look for another invite for that as well. And I want to thank everyone again for joining us. And we look forward to seeing you on the next session.
Thank you very much, everybody. Thank you for having me, Melissa. Pleasure to be here.
Thank you.